Today's lesson is on simplifying powers again, but today we're going to talk about powers of products and powers of quotients. So it seems like it might be something very similar to what we've already talked about with the products of powers property and the quotients of powers property. But these properties are a little bit different than what we have already learned. They have a little bit different property. And I think it's pretty intuitive, so you might be able to figure it out on your own what it is that we want you to see here. So we're going to start here with how could we write the quantity 3x to the fourth power in expanded form? Many of us might say, well, we could write that as 3x times 3x times 3x times 3x. Okay. Now, the need for parentheses here really is not that important because I can simply write this as 3 times x times 3 times x times 3 times x times 3 times x. So if I were to look at this, I could probably write this in a shorter form. Okay, this expanded way in a shorter form. So I'm thinking, okay, I have some 3's up there. How many times did I multiply by 3? I multiplied by 3. Let's see here. 1, 2, 3, 4 times. So that would be 3 to the fourth power. And I have some x's up there. How many times did I multiply by x? You can see I did that 1, 2, 3, 4 times as well. So x to the fourth power. So the big question becomes, well, we could always do this the long way, but that might take us forever. What would be the short way? So what do you notice about how we wrote it the short way up here, oops, compared to how we wrote it down here? Okay, how we wrote it after it was an expanded form. Hopefully what you notice is it looks kind of like since the 3x was in parentheses, it kind of looks like I took the 4 and I put it on everything inside of the parentheses. Sometimes we call it distributing. If that was a multiplication problem, we would call it distributing. So I like to think of it as I'm going to distribute that exponent to everything inside the parentheses. And remember, if something already has an exponent inside of those parentheses, my multiplication rule still occurs. Okay, so if that x had an exponent on it, I would have to do whatever the exponent is times 4. Okay, so I can give you a little example over here on the side. If I had parentheses 7d to the third power to the fifth power, I would have to put the fifth power on the 7 to get 7 to the fifth. I would have to put the 5 onto the d to the third, which gives me d to the 3 times 5. So d to the 15. Okay, so the exponent has to go to every single thing that is inside those parentheses. So that is actually our powers of products property. It says for all n, the quantity a times b to the nth power is really just a to the nth power times b to the nth power. And of course we want a and b not to be 0 because then we get a boring example. So that's our powers of products property. As you fill it in, as you follow along in your notes. So we have some practice problems here. I'm going to ask you to try them on your own first, and then, so pause the video and try them on your own first, and then go ahead and hit play when you're ready to check your answers. So here are the answers to those practice problems. You can see the first two are pretty simple, very standard, just like the ones that we went through earlier. The third one, I need to put that 4 on every single thing. So I need to put the 4 on the 3, so 3 to the fourth, on the x, x to the fourth, and on the y, so I get y to the fourth. Number 4 gets even a little more challenging. I have to take that 5 and I have to put it on the -4 to get -4 to the fifth power. To put it on the x to the third, so remember I have to multiply those exponents now, so I get x to the 15th. I have to put the 5 on the y, so that gives me y to the 5th. That is the one that most people overlook and forget to write down. And then we have z to the 4 times 5, so z to the 20th. The same idea happens on number 5. We have to give the exponent of 3 to the negative 5, so negative 5 to the 3rd power. X to the 2 times 3 gives us x to the 6th. Y to the 3 times 3 gives us y to the 9th power. I made a little mistake there. And then 3 to the z gives us z to the 3rd power. So, okay, so that would be number 5. And then number 6 is the one that kind of throws some people off every once in a while, because there's this 8 hanging on the outside there. So we're just not going to worry about him right now. We're going to worry about what's inside the parentheses. So we give the exponent of 3 to the negative 7. So we get negative 7 to the 3rd. Give it to the x to get x to the 3rd. Give it to the y to get y to the 3rd. And now the 8, he's just kind of hanging out on the outside. Now, this raises a really good question right here. Can we do 8 times negative 7 to get 56 and write 56, negative 56 to the 3rd power? Okay. And here's where I'm going to use my calculator. If I were to do that, I would get negative 175,616. Okay, now if I were to punch that thing into my calculator the way that I see it, so if I were to type in 8 times negative 7 to the 3rd power and I do this all as 1, I will get, if I can type it into my calculator here, I get negative 2,744. Okay, so we can see that these two answers are different here. These two answers are very different. So the question becomes, which way do we do it? Okay, the answer is we follow PEMDAS. We follow our order of operations. PEMDAS says anything that is in parentheses you do first, followed by anything with an exponent. So we would need to do negative 7 to the 3rd. We would need to calculate that first, okay? And then we can multiply. So our correct answer, the correct answer, if you wanted to simplify it, would be this right here, okay? The negative 2,744, because order of operations tells us that every single person has to do anything with an exponent before we can do any multiplying. And if we do negative 56 to the 3rd, we've multiplied 8 and negative 7 first before we've taken care of that exponent. So hopefully that makes sense why, if you wanted to simplify this, you would need to do negative 7 to the 3rd power first and then times that answer by 8. All right, so that takes care of our powers of products property. Now we need to talk about our powers of quotients property. So it's kind of the same idea. It says, how could we write 3 over 4, the quantity, to the 5th power in expanded form? So most of us are probably going to say, well, we're going to write that as 3 over 4 times 3 over 4 times 3 over 4 times 3 over 4 times 3 over 4. Okay? Now, there is another way to write that also. I could take everything in the numerator, 3 times 3 times 3 times 3 times 3, divided by everything in the denominator, 4 times 4 times 4 times 4 times 4. Okay? The shortcut here is that what I see in this one is that I could write that as 3 to the 5th power over 4 to the 5th power. So what looks like we did here? Well, it sort of looks like the same thing. It looks like we distributed sort of that exponent of 5 to everything on the top and everything on the bottom. So it kind of looks like whatever the exponent is, if it goes inside those parentheses, it has to go to every single thing in the numerator and every single thing in the denominator. That is actually called our powers of quotients property. Okay, here it is. The quantity a over b to the nth power equals a to the n over b to the n. Why does this help us? Well, now if I have a's on top and bottom, now I can simplify them. You may be using that quotients property that we talked about last time, where you can subtract your exponents. So this is hopefully leading us to something where we can simplify it down really, really far. So something that starts out looking really ugly and nasty ends up not being such a bad answer after all. So we have some practice problems again for you. I'm going to encourage you to pause the video, try them on your own in the notes, and then when you're ready to check them, go ahead and push play again. So here are the answers to those practice problems. Number 1 and number 2 are pretty straightforward, kind of like the ones that we started with earlier, where we just need to put that exponent on everything in the top and everything in the bottom. So we get 2 to the third over 5 to the third. Okay, number 2, again, same idea. Give that exponent to everything on the top, everything on the bottom. So we get 2 to the fourth over 3 to the fourth. Now, number 3, we start to get a little bit more tricky. We need to give that 4 to everything on the top. And if you remember, it's that a to the 6th power is in the parentheses. So we need to do a to the 6 times 4, which gives us a to the 24. And then we need to give the 4 to everything in the bottom. So 7 over 7 to the 4. Number 4 here gets even a little more challenging. Okay, number 4. We give the 5 to everything on the top, so we get 19 to the 5th power. And now we have to give that 5 to everything in the bottom. So it has to go to the 2 and to the y to the 3rd. So that's how we get the 2 to the 5th. And then 3 times 5 gives us y to the 15th. Number 5, we're taking it a step further. Now we have a number on the outside. Big deal. Do what you know, okay? We know that that 3 has to go to everything on the top and everything on the bottom. So we get n to the 5 times 3, which is n to the 15th, over 10 to the 3. And then that 5, he can just hang out on the outside. He's fine where he is. Okay, and then finally, number 6. This one is the one that I was talking about before. Why do we have this property? It's so that we can simplify things down as far as possible. So we start, we're going to ignore that 12 on the outside. We're going to let him hang out there. We're going to give the exponent of 3 to everything on the top. So 10 times 3 gives me m to the 30 over m to the 5 times 3 is m to the 15. Now what you can see in this one is that inside of my parentheses here, they have the same base. So what I can do now is hey, I have a rule for that. I remember, I think I'm supposed to subtract those exponents. So the 12 is still hanging out, but m to the 30 divided by m to the 15 means that we're going to subtract our exponents. So m to the 30 minus 15 is m to the 15. And now you can see that m is only written once in that expression, and that is exactly what we want. That's our goal, so that each letter is only written one time. Okay, if you look up above here, none of these have a letter that is written more than once. Okay, so A is only written once in number 3. Y is only written once in number 4. N is only written once in number 5. So our goal on number 6 was to get M so that it was only written one time in that whole problem. All right, so we have some green notes to fill in. We have the quotient of powers property. If you don't recall from last time, that said for all n, b to the m over b to the n equals b to the m minus n. So that should be for all n and m. All right, the next one, the powers of products property, that's what we just learned today. All right, that one said if I have a over b, if it said a times b, the quantity to the n, that was just a to the n times b to the n. And then the last one that we're going to squeeze in our green notes is this one. If we have a to the b, a over b to the n, that's just a over a to the n over b to the n. And that again is for all n. So that's it for today. We have a quiz to follow, and then you can go ahead and finish up with your OTL number 4.